Assalamualaikum and very good day. We are from Nizal and Teams Group who would like to make a presentation about welding process. Here are our member teams, which are the first one, Ahmad Daniel Wikarno, Sharif Muhammad Nizal Aiman, Muhammad Dafish Chazlan, Finances Fardex, and also Muhammad Nasrul Hakim.
There are two major categories of welding processes, which one the first is fusion welding. Fusion welding is a contact is accomplished by melting the two parts to be joined, in some cases adding filler metal to the joint. For example, arc welding, resistant spot welding, and oxy-fuel gas welding. While the second one is solid state welding, where heat and ore used to achieve contact, but no melting of the base metals occurs and no filler metal is added. For example, for solid state welding is forge welding, diffusion welding, and also friction welding. Arc welding can be defined as a fusion welding process where metal is joined using heat from an electric arc formed between an electrode and the workpiece. The heat source is the electric arc generates temperature up to 5500 Celsius, enough to heat any metal. Most AW processes add filler metal to increase volume and strength of the weld joint. There are some basic processes also used in the arc cutting. There are two basic types of AW electrodes, which are consumable, where the electrode is being consumed during welding process as a source of filler metal in arc welding, while the second one is non-consumable electrodes. Yeah, it not consumed during welding process, and any filler metal must be added separately. Arc shielding is required during AW temperature. The reason is at high temperature in AW, metals are chemically reactive to oxygen, nitrogen, and hydrogen. Mechanical properties of joint can be seriously degraded by this reaction. Therefore, to protect the operation, arc must be shielded from surrounding air in nearly all AW processes. Arc shielding is accomplished by shielding gases such as argon, helium, and carbon dioxide, and also flux. The power source of an arc welding is AC machine less expensive to purchase and operate, but generally restricted to ferrous metal, while DC equipment can be used on all metals and is generally noted for better arc control. As I mentioned, the basic type of electrode in arc welding processes. The example for consumable electrodes are shielded metal arc welding, gas metal arc welding, while the non-consumable electrodes example are gas tungsten arc welding, plasma arc welding, resistant welding, resistant spot welding, oxyacetylene welding, and also other fusion welding processes.
Okay, so for resistant welding, the main process is resistant spot welding (RSW). So the process is that join metal parts by using both heat and pressure. The heat comes from electrical resistance where the metal touch. So for the component we have four, which is first part to be weld, second two opposing electrode, third pressure to squeeze part, and lastly control current. So they have advantage. The advantage of resistant welding is first no filler metal, second is high production rate, third is suitable for automation, and lastly good repeatability. And the disadvantage is high initial equipment cost, and lastly mostly limited to lap joint. So the application of the resistant welding is mass production of cars, appliance, metal furniture. Possible welding is a process use high temperature flame from burning a gas with oxygen to melt and join metal part. The process is flame directed by a welding torch, sometimes add filler metal similar to base metal. Filler rod often coated with flux to prevent oxidation. And the safety, acetylene and oxygen are highly flammable. So acetylene is colorless and odorless. Process to have a godly odor and stable at pressure store in cylinder with porous filter and acetone. So for the application of oxy-fuel welding is fixing metal component and machinery, creating and shaping metal structure and parts, welding pipes and structural steel.
There are other fusion welding processes which the fusion welding cannot be classified as arc, resistance or oxy-fuel welding. It uses unique technologies for heat generation, often tailored to specific application. The processes include electron beam welding and laser beam welding. Electron beam welding, or short as EBW. The mechanism of electron beam welding. It uses highly focused electron beam which generates intense heat for welding. The electron beam welding has a vacuum chamber within it, which is used to minimize disruption of electron beam by air molecules. The vacuum chamber in the electron beam welding can be categorized as three types, which are high vacuum welding, medium vacuum welding, and non-vacuum welding. Advantages of electron beam welding. First, it has a high quality welds with minimal distortion. The deep and narrow weld profiles, and it has no needs for flux. The challenges of electron beam welding: it has high equipment cost and safety concerns because it has X-rays, and it requires precise preparation and vacuum chambers. Now, moving on to the laser beam welding, or short as LBW. The mechanism for the laser beam welding: it has a coalescing achieved by energy of a highly concentrated coherent light beam focused on joint. LBW normally performed with shielding gases to prevent oxidation, and usually the filler metal is not usually added. So the advantages of a laser beam welding: it doesn't need a vacuum chamber, and it's easier to direct and focus on the beam, and is generally safer than the electron beam welding because it has no X-rays. The limitations, however, for the laser beam welding: it cannot achieve the deep welds possible with EBW, and the depth is limited to 19 millimeters compared to EBW's 50 millimeters.
For the solid-state welding, it is a joining procedure where a combination is produced by applying pressure alone or pressure and heat. If heat is applied, the temperature is below the melting point of the metals being welded. Solid-state welding does not add filler metal. A successful solid-state weld are that the two fairing surface must be very clean and in very close physical contact with each other to permit atomic bonding. For the advantages, the metal surrounding the joint maintains its original characteristic. It's create welded connection that fills the whole contact interface between two pieces and can be used to join dissimilar metals without raising issues. There are 6 solid-state welding processes. First is cold welding. It is done by applying high pressure between clean contacting surface at room temperature bonding. Cleaning usually done by degreasing and wire brushing immediately before joining. No heat is applied, but the formation raises work temperature. Next is roll welding. Joins material by applying pressure with rolls with or without external heat. Then used for joining sheet and similar application, a variation of forge or cold welding. And then for the application, cladding stainless steel to matte or low alloy steel for corrosion resistance, bimetallic strip for measuring temperature, and sandwich coins for US unit. Fusion welding use heat and pressure low temperature plastic deformation at surfaces in minimal primary coalescence mechanism is solid state diffusion. For the application, joining of strength and refractory metals in aerospace and nuclear industries and can be used to join both similar and dissimilar metals. For the explosion welding, its rapid contact of two metallic surfaces is caused by the energy of a denoted explosive. No filter metal used, no external heat applied, and no diffusion occurs. Time is too short. Thanks for the friction welding. Coalescence is achieved by frictional heat combined with pressure. When properly carried out, no melting occurs at faying surfaces. There are two types of friction welding. First is continuous dry friction welding, and then initial friction welding. Lastly, there is ultrasonic welding. It is two components are held together and oscillatory shear stresses of ultrasonic frequency applied to interface cause coalescence.
This is a weld quality which ensures strong defect-free joints critical for performance, safety and durability. First, residual stress and distortion. These are managed using techniques like preheat, cooling and proper welding methods to control distortion. Next, welding defect. Common issues like cracks, porosity, solid inclusions and incomplete fusion, which are mitigated through proper material preparation and process control. Lastly, inspection and testing method. This involves visual check for surface defect, non-destructive testing method like ultrasound and radiography, and destructive testing to verify strength and structural integrity. Weldability is a capacity of metal or combination of metals to be welded into a sustainably designed structure and for the resulting weld joints to possess the required metallurgical properties to perform satisfactorily in intended service. Second, the characteristic of good weldability first is with which welding process is accomplished. Second, absence of weld defects. Lastly, acceptable strength, ductility, and toughness in weld joint. This is a factors of weldability. First, welding process. Some metals or metal combinations can be readily welded by one process but are difficult to weld by others. Second is base metal properties, which is melting point, thermal conductivity, and coefficient of thermal expansion. Third is filler metal, must be compatible with base metals. In general, elements mixed in liquid state that from a solid solution upon solidification will not cause a problem. Lastly, surface condition. Moisture can result in porosity in fusion zone. Oxide and other solid films on metal surface can prevent adequate contact and fusion. This is a design consideration in welding. First, design for welding. Product should be designed from the start as welding assembly and not as a casting or forging or other form shape. The second one is minimum parts. Welded assembly should consist of fewest number of parts possible. Example, usually most cost efficient to perform simple bending operations on a part, then weld and assembly from flat plates and sheets.